So hi everybody, we are still working on combinations and we are focused in this lesson on these problems 47 through 58. We'll assign a couple other critical thinking problems, but our goal is to use the combination formula, combinations, and also the fundamental counting principle. Now what this means is that you're going to have, in some sense, more than one idea happening, which is what the combination is. You might have a combination formula for each of the possibilities that occur. And so there'll be some different things here. We're going to do a couple of problems here right now. We're going to do 48 and 50 on page 626 in your textbook, and to give you a start. So we'll start that on the next slide. So the first problem we're going to do is number 47. It says, in how many ways can a committee of 4 men and 5 women be formed from a group of 7 men and 7 women? And so the way I would look at this problem is I have to make a committee that consists of men and women. So there are really, in some sense, 2 choices, and the question is how many men and how many women. And then by the fundamental counting principle, I would multiply those 2 answers together, because once I know how many men, I would then multiply that by how many women, and that would give me the different possibilities. So when I look at this, what I see is, in problem 47, I see that I want 4 men out of 7. Now there's no order to that, so that would be a combination of 7 men, choose 4 at a time. And in a similar way, I get a combination of 7 women, choose 5 at a time. And if I find those 2 numbers, then I would multiply them together. Using a calculator, it will give that 7 choose 4 is 35, and I multiply 7 choose 5, and I get 21. So my final answer is 35 times 21, which is 735 possible committees made up of 4 men and 5 women. Good enough? You got the idea? You see how the fundamental counting principle gets used, and we multiply combinations. So let's try number 49, and we'll see how we do there on the next slide. And so 49 says the U.S. Senate had 55 representatives and 44 Democrats and 1 independent. I think this was in the early 2000s. How many committees can be formed if each committee has 4 Republicans and 3 Democrats? So what I can see is that I'm forming a committee based on Republicans and Democrats. So very much like I had before, I got these 2 things. I'm going to multiply together. This will represent the Republicans, and this will represent how many Democrats. And so I have a combination of 55 Republicans, choose 4 at a time, times a combination of 44 Democrats, choose 3 at a time. And then I want to multiply that out. So 55 combination, choose 4, is equal to 341,055 possible Republican combinations. And the Democrats, their number of combinations is 13,244, Look at how much extra you get just from those 11 extra people. That's remarkable. And then you multiply those two numbers, and you get, oh my gosh, 4,516,932,420 possible committees. Okay? Once again, the key idea is we use the multiplication principle and we multiplied two combination ideas. Now, just so you know, if you go to the next set of problems, which runs from 51 through 58, what they do is they give you 6 jokes. And then they ask you a bunch of questions about those jokes. And those questions could be permutations, could be combinations, or could be these combinations with multiplication principle or fundamental counting principle problems as well. So you just have to work through these, each one of these, and make sure that you can do them. And make sure, since they're all mixed up, that you understand the differences between each problem. The last problem I'd like you to do is I would like for you to look at problems 63 and 65 as well on your homework. And I will probably assign you the evens up through 58. But these last two problems are classic problems. Number 63 is about what's called a 653 lottery, which means you got to pull 6 out of the 53 numbers. And the question then is about which lottery is easier to win. Would a 653 or a 536 lottery be easier to win? And so you're making some comparisons there to see which one is easier to win. And that's kind of a nice thing to do if you think about lotteries. The other problem is the classic handshake problem. And the classic handshake problem is if you have a group of 20 people and every person has to shake hands with all of the other people in the group, all right, how many handshakes are you going to have? And then based on that, suppose each handshake lasts 3 seconds, how long will all the handshakes take? And also you can't shake the hands of a person twice, so you throw that out, so there's no repetitive handshakes. And let's see, those are pretty good conditions. So I'll let you kind of think about those two, not necessarily combinations, but they might be. And so our goal is to always kind of ramp ourselves up and see if we get something a little different. So I'm going to pause this. This is a quick video to load, and I hope you guys have a good evening the rest of the evening.